Hello, ladies and gentlemen. My name is Robert Abel, and I'm the content coordinator of FC Magazine. It's my pleasure to welcome you to today's webcast, Bridging Network and Endpoint Security, sponsored by LandCope. Security operators detect and respond to threats by examining data generated by networks and endpoint monitoring tools. One of the biggest challenges is bridging these different types of tools. Our presenter, LandCope's consulting security architect Charles Herring, will examine workflows used by mature SOC and IRT practices to efficiently resolve security investigations. Charles began his information security career in 2002 as a network security analyst and as a network security officer with the U.S. Navy. Quick note, there will be a Q&A session following the presentation, so we encourage anyone to type any questions you may have for him via the interface. And welcome, Charles. We're pleased to have you with us today.
Well, thanks a lot, and thanks for everyone for joining today. We're going to go through some workflows that are commonly used in security operations centers and incident response programs. Some of it's going to be pretty high level, but I do want to give some concrete, tangible examples on how to execute on them. As was mentioned, I started my career as an analyst in the U.S. Navy, trying to build processes around incident response. And the trouble was there is no documented standard on the actual flows. There are great playbooks from NIST and others that allow guidance on what things we should look for, but not so much guidance on how we look for them. Add to that, we have a challenge of the network team or network security teams owning network data and other teams owning workstation data. So how do we bridge the investigative cycle? So just a couple of quick notes that this is the screen that scares you, right? The obligatory screen that there are problems in security, and much of it does revolve around insiders, and we'll look at how the users play a part in this because they are interfacing with the endpoints, with the workstations that are contributing to the data, or at least the data we need. So real quick, when we look at a data breach or any other type of event, there's several steps that occur. There's a modus operandi that's associated with a given attacker or a given adversary. But they're almost always going to start with some level of reconnaissance. Some of it will be a public level reconnaissance by looking for members or administrators or other users' information on social media sites or other places of information. They'll craft a spear phishing type of campaign. This, of course, is not the only way to deliver malware into a network, but it is a common one because it's exploiting all the different conditions of the human condition that would allow someone or encourage someone to click onto a link they shouldn't and download malware. There's, of course, many other ways, put in a thumb drive and other things. But in this little example, we have an external attacker. The network has to be used in transmitting the attack. A user is involved in this one where malware is deployed, so processes are generated. And so we're going to have different types of networking logs that are going to be a part of the investigation. We'll have endpoint data that needs to be collected, and so we're going to go through how to connect those things together here in a second. But first I wanted to hit on how we bring that data together. Really the holy grail of information security is putting it all in a single pane of glass, to have one tool set that we could look at. And I've worked in software security sales for a long time, and I hear it often that there's some single pane of glass or some way of wrapping all the data into a single interface. The problem is it doesn't really work. And I want to talk about why, and really an alternate approach that does work. So one of the challenges or the goal of single pane is to put everything in a single display, and then the alternate approach is using what I call the right pane of glass, or the right pane at the right time. And so that's using different applications, but stitching them together using some type of connective tissue. One of the main problems in a single pane of glass is it requires it to understand several domains of data, the network, the endpoint, users, and so forth. Where a single application that's built to do network forensics or endpoint forensics or intrusion prevention on the network, those things are built around a very specific vernacular that allows workflows to be built that are specific to that type of data. And in a single pane of glass, it sounds great to have flexible workflows, but the challenge is you have to create ad hoc workflows and document those. So the way that you may use a single pane of glass, a SIM, for example, that you're digging into data and looking for data, there's workflows that are necessarily built around resolving a specific piece of information. Whereas if you look at something more specific like an intrusion prevention system like Cisco's Firepower or Stealth Watch, those are built with a much more precise workflow using a much smaller vocabulary. And the other really important thing here is a single pane of glass is just theoretical. It really is a holy grail that I do hope we someday get, and that it works and we're able to get all the information in the right context at the right time. But until that day comes along, we're going to have many more events and breaches and things that we're going to have to address. And so to handle that, we need to use the right pane at the right time. So today I'm not going to go down the path of trying to explain how to build a single pane of glass or protect when it might actually exist. We're going to look at how we can solve these operational issues of stitching together network and endpoint data with the right pane at the right time. So when we're running through an investigation, there's a handful of questions that we have to answer for the investigation to be worth our time, to give us operational, useful information to boil up and prevent a breach from happening in the future. From the endpoint perspective, we need to resolve what process was creating the malicious behavior if there was malware involved. If it was just a user, we need to resolve that it was a user. But we need to find what executable, what binaries are actually contributing to malicious behavior. We need to resolve this. Is this the first time it's been seen in the wild, or is it documented through global threat intelligence? Once we find the machine that's infected, we also need to find out what did that machine do while it was infected or compromised. Did it communicate with critical machines? Did it communicate with things that are in scope, like PCI machines or other machines that have PII on them? And so being able to resolve that is going to be a network inquiry. It may be a logging, but almost certainly going to be a network inquiry. What users were involved in the communications or the processes, which user accounts, and it may not just be maybe an actual human being that was compromised. So we see this increasingly where users are taking bribes to do malicious things, or it may be a user's credentials are stolen, as in the spearfish or in a spearfishing attack. But we need to document which users and which credentials were used in the attack. And this part gets skipped mostly because we run out of time, but it's also a tool level issue. Once we finish an investigation, we have a picture of what the adversary did, how they got in, what they did once they were in, what machines were accessed and utilized. And so we can build an MO, a modus operandi, for that adversary, things to look for, the indicators of compromise that we can retroactively look for. So what external IP addresses did they come in from? Where did they try to exfiltrate data to? What was the nature of the malware used? What credentials were used? And build up these different IOCs, and then retroactively look through our data stack for communications that meet those markers, for binaries or processes that also meet the patterns. And so what that allows us to do is answer the question, is this the first time, or is this an ongoing systemic problem? If you remember back to when the Mandiant APT1 report came out, there was a long list of IOCs, and the industry went through all those IOCs and wanted to see were we affected by that attribution back to PLA. Were we in that mix? And so to do that, everyone plugged in the IOCs into the tools they had and went back and looked. Well, that is a healthy thing to do, but it's even more healthy to do internally. If someone is an adversary to us, to our organization, at the end of every investigation, we should go back and look to our historical stack and determine, is this a problem we need to address broadly, or is it a one-off incident? So from a network perspective, one of the things that I have the most experience with is working with NetFlow. And NetFlow is a metadata record coming off of routers, switches, firewalls. They can come off of endpoints now, and they collect a number of characteristics which can be used in forensic investigations. Things like what IP address talked to what IP address, what ports were used, how many bytes were exchanged, the timestamps, of course. And then as NetFlow has evolved from the early days to today, flexible NetFlow or NetFlow version 9 and IPFix, the open source equivalent, allow us to put additional information into those NetFlow records. Things like what user was generating the flow, perhaps the MAC address of the machine, performance metrics, application generating, and all of those things can be defined by the device as generating the metadata and forwarded on to a collector. And another nice component of NetFlow is that it's very compact, which allows us to do two things. It allows us to store it for a very long period of time. Many of the organizations I work with store NetFlow for 6 months or longer, which allows them a really big stack to not only resolve the current incidents that are occurring inside the network, but also when they need to perform a retro analysis on the indicators of compromise that they were able to resolve during an investigation, they can go back 6 months or a year or longer. So the compact nature of NetFlow works in that regard. And it's also very helpful in processing. When we're doing full packet capture, that's a much heavier thing to run queries against. And so we can, in doing NetFlow queries that have been indexed or NetFlow against a NetFlow data stack, we can resolve very quickly in seconds or minutes very complicated queries that would, or queries would be very complicated inside of something heavier like full packet capture. So that's the second nice thing about NetFlow. And finally, the pervasive nature of NetFlow. Many organizations, as Cisco's rolled out switches like the 3850s, we've been able to get NetFlow from the access layer. So we're even seeing a workstation before it leaves a given segment. And we can deploy that visibility to essentially converting the network into a sensor in virtually no time, and just point all the collection to a NetFlow collector. So NetFlow is a very powerful part in getting us that network data. It's also helpful in network behavioral anomaly detection. So here I have a snippet, and I don't know how well it's coming through, but these are some high-level process blocks that I review with our customers on things we should be doing in a given investigation. Of course, we begin it, we quarantine the host, and then, we determine what the host has touched. So going back, determining impact. And so this top block underneath the letter B is determine the host touched during the event. So the machine is known, in fact, that if a user is known as being malicious, we need to determine every conversation that host had. So we can do that through flow analysis. The next one is performing retro analysis of the communications. Okay, we found out what would happen, what the pattern of the attacker looks like, how he gets into a PCI server. Is this the first time it's happened, or is this pattern been going on for some time? So it's retro analysis or retro flow analysis. And then the next step is taking those bad network behaviors and tying them to the machine, which is really the crux of this conversation, of this presentation, which we'll get to in a second. And then finally doing retro file analysis. If this file was found, how do we find it elsewhere on the network? So just to highlight that, these two boxes in the orange are done inside of a NetFlow tool. This box is done inside of an endpoint tool like Endpoint AMP from Cisco, or something from Guidance in case. But then the real question is, how do we bridge these, right? how do we go from taking a network behavior and getting it to the actual process? How do we pivot from the flow to the file? So this is very hard to see, but one way we can do it, one approach, is doing what's called a pivot by IP. So actually, I'm going to come back to this slide in a second. Let me go to this one first. So when we look at the data that's available in these two stacks, it becomes pretty obvious why. Let me fast forward through this. Talk amongst yourselves. All right. So when we look at the data that's available in each stack, files are generally you have the process name. You also have a hash, a SHA-256 hash, or something along those lines that allows you to mark or know that that process is that process. Inside of flow cataloging, that doesn't really exist. You have this IP to this IP to this port. You have query criteria that's used to identify communications. On the file, you have an endpoint behavior. So a machine like, or an application like Endpoint AMP may see a machine reading the entire address book and trying to send email out, or downloading a DGA, a domain generation, or using a DGA to download a key to encrypt the disk on a ransomware situation. On the flow side, you'll see network behaviors like scanning the network type of behavior, or breaking segmentation or policy violations on the network using prohibited services. On the file side, you may see something like file trajectory. Where does this file exist throughout the organization? What's the history of this file? What's the first time that this file hash has been seen inside the organization? So Endpoint AMP and Network AMP from Cisco does that very well, looking at the history of a file across multiple machines. Flow history can be used to give you a profile of what does this machine normally do? What does this host normally consume on the network? Is it always consuming onion routing, or is it consuming something greater than that or different than that? Threat intel on both. So for files, it's much like a signature. You send up the file, it'll give you a dispensation. Wow, on disposition. It's disposition, not dispensation. Disposition of the file. Same thing on IP addresses or URLs on flows. And then one piece of interesting information that's available on both in different approaches is credentials. What user is executing that file, or what user credentials are executing that service, and on the flow, what user credentials are, what user is generating the communication. And so on the flow side, NAC solutions, most notably Cisco's Identity Services Engine, will log what user is on a given machine. That will be stitched into the flow information at the StealthWatch level. And so we can tie together at the credential level files and flows, so we start doing user type of connections. And one thing that's starting to happen is we're starting to see a process information coming out of NetFlow. And so if we have AnyConnect running on an endpoint, AnyConnect 4.0 with a network visibility module may become aware of the process that's generating communication. It can put out that process information into the NetFlow record. And so when we're looking at the flow record, we have the process, we have the machine, and now we have some connective material to pivot upon. So going back one slide then, this is, forgive my resolution here, but this is a report from AMP from Cisco. So if we start with an IP address inside of StealthWatch, let's see, my slides are a little out of order, we can pivot, and I'll show you how this pivot works in a second. We can pivot from StealthWatch into AMP on the IP address. So, okay, this is great. This machine's doing something weird. Let's look at the processes and the endpoint information there. So just passing the endpoint, noting the IP and passing the IP. Pivoting to another tool inside of StealthWatch is pretty easy. We have these configurable commands to where we pass the context into a URL. And this is the primary method for pivot between panes today. So looking at this integration of, okay, we have Threat Grid, or we have AMP, or whatever the tool may be, and creating a connector that allows the investigator to click on that thing and pivot to the right pane at the right time. In this case, it would be pivoting to threat grid for Intel. So that's useless in there. Okay. The other one is, as we discussed, pivoting to user. This is a very neat scenario. So if we collect credential information on NetFlow records using Identity Services Engine, and we also have, by nature of Endpoint AMP, the process is connected to the credentials, then we're able to correlate based upon the user and pivot that way. And so the connective tissue becomes pivot, right-click, take me to user. In this case, I know you can't see this, forgive me, but J Price inside of AMP. And so now we're looking at all of the machines and all the processes that J Price has created or initiated using those credentials. And so then we can look at which process is generating the network behavior. And so this is a really quick way of getting from a network visibility over to the endpoint visibility just using user credentials. And so the first one is IP. Of course, the problem with IP is DHCP. User credentials are a very interesting data point, though, in that they don't have very much variability. The usernames tend not to be reused in organizations. So, Landcope was recently acquired by Cisco, and we have some employees at Landcope that are now have moved back to Cisco once they, in a past life, were working at Cisco, and their user IDs just had to be reactivated, and that we don't recycle user IDs because they provide connection to that individual through all of time. And so this makes a user credential one of the most stable pieces of attributes for us to query against when we're looking at information. So collecting user information on the endpoint, collecting user information on the network allow us to do the most clear connection that's available today. I already went over that one. And the other one is pivoting back to process. So when we look at, we determine what the process is. We went from we saw bad network behavior, that network behavior to the machine snapshot. That snapshot tells us the process. The next question is we want to retroactively look at the processes across all the machines across the entire network. And so that is the retro analysis on the process side, and so we cycle through it. So, but those are the major ways. I realize I just went through this in 20 minutes, but the connective tissue is one, pivot by IP, two, pivot by user credential, which is currently the best thing available, pivoting on process when it's available. And the thing about pivoting by process is this is just now becoming available. As we start having more agents installed generating network telemetry, this is also being driven by the movement to the cloud. As we move services up to the cloud, we can no longer use the network infrastructure to generate net flow, so we're putting agents for the time being on those clouds, and those agents are able to give us process level information and user level information in their NetFlow export. Same thing with the AnyConnect network visibility module. So, again, the connectivity are users, IP, and process. Those are the three connective tissue the three pieces of connective tissue between network intelligence and file intelligence. So I'm probably going to give you most of your time back. Are there any questions out there that I can answer? I know I sort of rattled through that pretty quickly.
Well, thank you. Can you hear me? Hello?
I got you.
All right. Well, thank you, Charles, for your presentation. And, yeah, we can take a couple of questions from the audience. Our first question is it better to start the investigation with network security analysis or endpoint security analysis?
The trigger of a process is going to be based on what the notifying event was. So if the event started because you received an AV alarm, you'll start with the AV. If it comes in through an alarm from a network device like an IPS or IDS, you're generally going to start by parsing that information. But the second step is once that's going to give you situational awareness around the investigation. The second step is going to be isolating the affected machine so that so the event doesn't get worse, so the fire doesn't spread. And then at that point, once it's contained, the first standard step is going to be looking at network communications because we want to come up with a list of questions that we're going to take to the endpoint, such as what was generating the control channel, right? What process is generating the control channel, or what process connected to the known bad guy. So we do want to evaluate the big picture before going to the most specific. So the broadest picture will be the network, and then as we gather the network information, it's going to help us fine-tune the questions that we're going to pose to the machine once we have our hands on the disk and the memory.
All right, thank you. Our next question, how do virtualized environments affect this process? So
in both of them are about gathering the telemetry. So inside of VMware, so we're not talking about cloud, but inside of vSwitches that have become available over the last 5 or 10 years, most of those can produce network telemetry inside of the virtual estate. So you can just turn on, whether it's a Nexus 1000D from Cisco or the native VMware vSwitch, you can send that flow out. So that way it's no different. And then if you're using the same type of agents, whether it's Encase or Cisco's Endpoint app on the endpoint in the virtual estate, you're fine. The challenge is the paradigm has really occurred. This becoming challenging is the move to cloud, and that there is no infrastructure that we own in the cloud. And I'm talking about public and private cloud that's owned by the organization. So in that case, all of it has to be done agent-based until the fabric, until the switches that are built for the cloud are able to give network telemetry. And so there are several solutions out there now that are bridging that gap in the interim. But that is certainly one. We saw the same thing happen in the virtual estate when the black boxes showed up and we lost all visibility inside of them. That's since been fixed. And industry-wide now we're trying to figure out how to fix the lack of telemetry coming out of the cloud. So in the meantime, it's agents just like it was in the VMware days when we didn't have visibility or on the vSwitch.
All right, thank you for that answer. Next question. Can you use this to find insider threats who are not using malware or other technical means?
Right, and so that is one of the challenges, and that one of the results that come out of an endpoint investigation is that there was no malware. And so if you are approaching, if you're noticing data problems or network problems such as prohibited access or excessive access, so one of the things that StealthWatch does is it counts the number of bytes that a host or user collects from the network. And there's alarms that trigger, one being suspect data hoarding, that someone's collecting too much corporate information. Another one may be suspect data loss, that someone's sending too much information out of the network. And so in those cases, you're going to go and take the list of questions, what process sent the information out, and you may get to the endpoint and find there is no malware, that the malware is a human being, and the program that was used was Internet Explorer or whatever, or FTP or FileZilla or whatever tool they chose to use to exfiltrate data. And so in that way, it is very important to watch the network behaviors where endpoint is like watching the cars or what's going on inside of a car on the highways, and the network is watching the actual highways themselves for problems. And so it's very important to be layered in that approach, and certainly StealthWatch is uniquely able to alarm when those things happen. But certainly the end of every process isn't malware found. It can be that the malware is actually a human being, right? It is the insider, the malicious insider. All
right. Well, that will be it for today's session. Special thanks to Landcope's Charles Herring for sharing insight and expertise with all of us today. And also thank you to everyone out in the audience for taking part. As a quick reminder, this webcast will be available on demand beginning tomorrow on the SC Magazine website under the Events tab. Goodbye, everyone, and have a great day.